And then Dr. DUrso, I will pass it over to you.
Well, you know, my heart is so happy tonight. So happy. First, I want to congratulate Dr. Rutner on her continued support of this group. You may all know, I don't know if you do, but I was Lisa's chair, and she was one of my best students ever, one of the best, okay? And I'm just so proud of her. I'm so proud of the work that she's done and that she continues to do. And so I'd like to just thank her publicly for her contributions here.
Thank you, Dr. DUrso, for teaching me to get to this point.
Well,
It's all because of you.
No, you did the heavy lifting. And my heart is happy because tonight or today, I learned that we have another dissertation on the dean's desk for signature, and soon we will have Dr. Jordan Clint join the ranks of the doctors. I'm so proud of him. He's one of my best students. And he moved very fast, very fast. I had to run so fast to try to keep up with him. And I'm just so grateful because I see the fruits of our labors. It's just wonderful. So Jordan, congratulations, young man. You're just 1 or 2 steps away now. All right. Okay, anyone else want to say anything before I bring up my presentation? No? Okay. And I think it was important to, you know, mention the fact that we have some qualitative people in the house, and that's understandable. This information just can help you think a little differently. Not that you want to change your method. We're not here to do that for you. We're here to help you maybe think a little differently about the quantitative aspect of any study, whether it's qualitative or quantitative. There could be that aspect that's there, and this could help you a little bit in understanding how the other side works. Okay. So tell me if you can see my screen.
Yes, we could see it.
Okay, very good, very good. So I want to share with you that I did a similar presentation about a year ago on G-Power. And I know G-Power is very confusing for some. And I had some really wonderful comments afterwards. And so I thought, well, maybe I should come back, particularly if you have some new people who could benefit from these very elementary comments about G-Power. And so here I am almost a year later and talking about the same thing. But I've added a couple of slides and I've changed a few words. I promise you it's not a carbon copy, okay? So tonight what I'd like to do is to talk a little bit about how we navigate G-Power, how we demonstrate that we have in fact used a scientific sample size software to arrive at the sample size that we're trying to defend. And that's what the dissertation is all about. We have to defend what we've done either by using other dissertations, studies in the literature, things from trade journals, books, textbooks, whatever. So this is one way that you can demonstrate and provide evidence that you knew what you were doing and that you arrived at a scientific sample size. And we'll talk about this as we go along. The second thing I'd like to do is to give you, and I hope you don't feel like this is cheating, but I'd like to give you language that I excerpted from one of my students' dissertations about how to represent what you've done in G-Power, because there are a lot of moving parts in G-Power. And so I'm going to give you real life language. And I hope if you like it, and those of you doing a quant study, if you're going to use it, please modify it, paraphrase it, and cite it, okay? I know you'll do that. And then I would like to show you what you have to do for your appendices relative to G-Power. You do have to put a screenshot into the appendix to show your committee that you did, first of all, calculate the right statistical test. And secondly, that you arrived at a correct sample size and what the values were that you inserted to get to that sample size, which sometimes can be a little confusing, but it's very doable. Okay, so those are the things that I'm going to emphasize tonight, but I do have a few other goodies in this presentation that maybe will be helpful to you. So here's just a list of a couple of links that you might find useful for G-Power link and the G-Power manual, and I'll talk about that in just a minute. If you're doing a quantitative study, and I think some of you are a little new, fairly new to the program, and maybe you don't know for sure if you're going to choose quant or qual. One thing to do is to understand both as best you can. I know that's a lot of reading. I know you have a lot of work ahead of you to understand the aspects and the peculiarities of qualitative and quantitative analysis. But if you're sitting the fence because you don't know which method you should use or you want to use or would be best for you to use, one of the best things for you to do is to start reading about both methods, and then you'll know a little better. So here, and you'll get a copy of this PowerPoint. So here are some links that can help you, okay? And the reason I have a multiple regression link in among these indices is because we do a lot of multiple regression quant studies at GCU. They're powerful and they work quite well, okay? Now, in order to generate a scientific sample size, you need software. There are several software packages out there, and we could go through those at another time. But the standard for GCU is to download the G-Power software. That's really important to get you started and to get you started quickly. So if you're relatively new at this and you haven't thought about how am I going to determine my sample size, because maybe you're not there yet in your writing or in your reading, this is one way to get started. And the reason that I'm emphasizing this is because there are so many resources in the G-Power software and the manual. Just take a look at this slide just quickly, and you will see that I've given you a link to download the software. Now, if you have trouble downloading the software, tech support does support the G-Power software and SPSS. So, try them, see if they can help you if you have trouble. But get the download and put it on your computer so that maybe you want to refer to something specific when you're answering a DQ in one of your courses. You'll find plenty of good information when you download this software and when you download the manual. Right here, you will see a long link and you will be able to download your version, and there might be an updated version. Right now I'm using 3.1.9.7 and it is sufficient for what I need to do, but there might be a newer version. So when you go to this website, perhaps it will tell you this is the version we're using now. So it might be 0.8 instead of 0.7. At this website, you will find lots of little tutorials and write-ups and information, such as a simple sample t-test, a paired sample t-test, independent sample t-test, two independent proportions. We don't see too many proportions, but once in a while we do. A one-way ANOVA, two-way ANOVA, multiple regression. What isn't in here is correlation, but we do know we do a lot of correlation, and we do a lot of predictive correlation, which leads us to doing multiple regression. So these are just a few of things that you can go in and read about. And I think if I clicked on one of these, it would take us out there. But I don't want to, we don't have time to go down that rabbit hole. I'd be happy to do it with you one-on-one because I kind of find this fun and I enjoy this quite a bit. So that's your download. That's your link to get the G-Power software on your computer. The next best thing is the G-Power manual. And the manual is available to you free of charge at this website, the same website that, or a related website that you can get the download for the software. Now, it's not a small or a short read. It's quite a document. It's about an 85-page manual in PDF format. And so I find it hard to read sometimes. I'll be very honest with you. I'll read something the first time and I don't really know what they're talking about. And I'll read it the second time. And if I'm still confused, I put it down, I go away, maybe come back the next day and I'll read it again. And so sometimes you have to read 2, 3, 4 times and practice a little bit before it really begins to sink in. So again, get your hands on that G-Power manual, start to look through it. Don't let it overwhelm you. You just take, how do you eat an elephant one bite at a time, right? So just take your time and go through it and identify the sections that seem to be where you're going with your method and design and kind of spend some time there. Okay? You might find later though, that you're going to change your design, in which case you have to learn a little something different. That's not a big deal most of the time. So I spoke earlier about the language that one uses when you've decided on the sample size. Now, why is the sample size so important in quantitative studies? Well, we have to be convincing and we have to be able to defend what we found when we go to our AQR defenses, right? And so one of the first questions that people ask in any defense, but mostly in quantitative, is how many were in your sample size? And I tell the story of, when I, do the stats classes live, I'll say, if you learned that 3 out of 5 dentists recommended Colgate, and then you learned that there were only 5 dentists that were surveyed, you wouldn't run out and buy Colgate, right? You'd try to find out more information. Well, that is the principle or the philosophy behind trying to identify a scientific sample size. We need to have good, large enough samples that if we find something profound and we want to support the profundity of our topic with the information that we collected, the data we collected, the first thing that'll, set the train off the track is having a small sample size in a quantitative study. So that's why I'm here tonight, is to emphasize how important that larger sample size is for a quant study. Okay, so let's read this. Let's get an idea of what this student said about what she did in her study. We do analyses a priori, which means before the fact, and post hoc, which means after the fact. And you will do both, usually, in a quantitative study. And so as you're writing up chapter 3, you're going to have to talk about the a priori analysis. As you write up chapter 4, you will talk about the post hoc analysis. So this student did an a priori power analysis. It was typically performed when designing a quantitative study. Parameters for this quantitative predictive correlational study were set at a 2-tailed test with a 0.0125 Bonferroni adjusted alpha error probability and a power of 0.8 and a medium effect size of 30. Boy, that's a mouthful, isn't it? But I'm telling you if you follow what I'm about to show you, these numbers will come to you and you will be able to use this language and insert your own numbers. The difficulty with this particular language is the Bonferroni correction, because this student had a couple of predictors, and every time you have a few predictors on the criterion variable, you have to use a correction. So that's what the Bonferroni correction is. If you run into a problem, you just get in touch with me and I can explain. If you tell me about your study, I can explain whether or not you need the Bonferroni correction, or your committee will help you with that. So the Bonferroni correction became 0.0125 when ordinarily it would be a p-value of 0.05. Okay, so that makes this just a little bit different. There were multiple analyses on the same criterion variable, and that increases the chance of committing a type 1 error. Now, I gave you the citation and the reference for Field. Andy Field is wonderful textbook for quant studies. Please get your hands on it. I don't know if you can get it electronically. I have the 4th edition. I think there may be a newer edition out. It's wonderful. If Andy Field said it, it must be good. It must be right. So I'm telling you, that's a good source for you for just about anything quant. So based on the G-power, the a priori analysis for the Pearson's R, and the R is in italics, it's a coefficient, and R is a coefficient for Pearson's. You will find that if you're doing a Pearson's correlation coefficient. Using the Bonferroni correction, the required sample size was 119. So if you have 119, that's a minimum sample size, okay? I might say that again, because that's really important. In quantitative studies, we anticipate, a couple of things could go wrong, and sometimes they do. And that means that you don't have the 119 in this case that you counted on. And you have to have 119 or be around that number, very close to it, one way or the other. But if something happens and you lose participants, then you're in a little bit of trouble. So if you plan for attrition, if you plan for missing data or significant outliers, and you have not chosen a statistical test that would allow for you to drop off those outliers, or to conform or convert missing data to maybe a mean score in those empty cells, then you're in trouble, because maybe you've fallen under that scientific sample size of 119. So we ask you to put at least 10 to 15% on top of the sample size that is calculated and output by the G-Power software. And I can answer your questions on that a little bit later, okay? So remember Andy Field. That is really a wonderful, wonderful source. So I want to talk a little bit about type 1 and type 2 errors, because quantitative studies do have the potential for errors. And before I go into the words on this slide, I just want to mention that the conventional alpha for most quantitative studies at GCO, I don't want to say all, but most, is 0.05. That's the p-value, the significance level that we operate for our p-values for our dissertations at GCU. However, that alpha level, which is an error level, and it says 5% of my data could be in error, is really important for social science research. If you are working in medical science, perhaps you're doing life and death research on clinical trials or cancer patients, whatever you're doing, that 0.04, you can't afford to lose 5 out of 100 patients, right? So that 0.05 would not be applicable. In medical science, that sometimes they research at 0.0001, 1 in 1,000, 1 in 10,000, 1 in 100,000. And sometimes if you go to the doctor, they'll give you those stats. They'll say, the risk is so minimal, it's like 1 in 100,000. And you think, where did they get that? They pulled that out of their head or what? No, they actually did research like we do in dissertations, but they used a very, very small, very tight, very rigid calculation at, let's say, 0.0001. We have conventional alpha at 0.05 for most of our dissertations. So the type 1 and type 2 errors that you could face, and I'm using the legal system as an example. I think everybody can identify with my example here, is sometimes juries make errors, don't they? And we've all heard and seen programs and heard of people where the innocent person actually gets convicted and goes to jail. And statisticians have called this a type 1 error. Civilians call it a travesty. So if you know you're doing a study that has the, and you'll know this by reading, and you'll know this by learning about your design and the statistical test you've chosen. If you know that your study has the potential, as remote as it might be, to get a type 1 error, then you want to read about it and know about it and do whatever you can to avoid it. Okay. And again, that's time for another presentation. We can talk about that at another time. The type 2 error is the guilty people go free. Now you see the difference here. The innocent person goes to jail, that's a type 1. The guilty person goes free. Now, we're not going to get in a debate tonight about which is worse. Which would you rather see? We don't really want to see either, do we? But these things do happen. These errors do happen in research. I gave you the reference, the citation here for understanding a little bit better about the type 1 and the type 2 errors. Now I'm finally getting to the fun part and the meat of it, and I'm sorry this is small. I have tried so many times to make it bigger, but I haven't been successful. And the same thing happened in the last presentation. But you will see, if you just lean into your computer a little bit, and if your glasses aren't dirty, you'll be able to see that we've got a little chart there for G-power, the output. And we see the alpha in red and the beta area in blue. And we also see that we have some choices that we have to make. And I will demonstrate this live when I pull up the G-power software, but just look at this. You can see that we've got an effect size of 0.15. We've got that error probability that I talked about at 0.05. We have a power of 0.80. And we have number of predictors in this particular study. I entered two predictors, okay? So all of this on the left-hand side where you see the entries of 0.15, 0.05, 0.8, and 2, I put those numbers in, okay? Now, some of them could be a default. In this case, when I selected the linear multiple regression fixed model with a big R squared, deviation from 0, that's the whole test. That's what I selected there, and it's an F test. The default of 0.15 was entered already when I called it up, and I think 0.05 was already in there. But the default for the power was 0.95. And 0.95 would have raised the sample size considerably. And GCU is okay with using 0.80. And so I used 0.80. And I got a sample size of 68. So I calculated, and the right-hand column was populated. Now, as you look at this, you can see a couple of values about non-centrality values and critical F. And you can use a chart that tells you if you're below or above the critical F, what you would have to decide. And again, that would be like another time for this presentation. You will see denominator and numerator and total sample size, and then you'll see actual power. And those 4 values are important. The numerator has 2. The denominator has 65. The total sample size has 68. Now I know just about every one of you probably has added this up. And you see 2 and 65 gives me 67. What happened to the other one, right? Well, the formula for degrees of freedom, and the degrees of freedom are those elements in a quantitative study that are free to vary. They can move around. The formula is n minus 1, n meaning your sample, n minus 1. So if you look at that 1 that's hanging out there, plus the 2, plus the 65, it takes you to 68, doesn't it? Okay, so there's that. And we're going to look at this a little bit closer if and when I pull up the software. I hope it doesn't give me any trouble. Now, there are some quite complex, involved, complicated quant studies out there. And if you're not sure about your stats, and if you're not sure, maybe you didn't have any stats, or it was a while ago since you had stats courses, you might want to select a more simpler design, a more simpler type of study. Dr. Jordan Clint chose a very complicated study. He had so many moving parts. I had to sit down and rest when I was reading his document. But he handled it because he knows his stats. He did a great job. If you don't feel that confident, you probably want to back off or take a step back and think about it, and then say, I'm going to do this. And you won't let your pride get in the way. You'll look for help. That's what you do. So I say here that some quant studies are more complex and involved, and that's true. And they can confuse the researcher, particularly if this is the first time you've ever done research at this kind of level. This is a high level of research. So what you would ask yourself, what test should I use? Laird is one of the first and the greatest places to start. You can get so much information there. And the link or the website address is statistics.laird.com. For students, it's a minimal membership fee. You can, if you can afford the year, buy it for the year and study the whole year. If not, you can wait a little bit longer and you can buy your membership for 6 months when you get to the place where you're writing up chapter 3. The fun part about Laird, and I would love to come back and do this little exercise with you guys, they have a statistical test selector. So you can go into Laird, it's interactive, and Laird asks you questions, and you answer your questions. For example, they'll say, how many independent variables do you have? And you can say 2. And are they continuous, or are they dichotomous or categorical? You can say they're continuous. And how many criterion variables do you have, or how many dependent variables do you have? You could say 1. And then you continue to answer those questions to the end. And at the end of this interactive program, it tells you what statistical test you should use. I mean, I think it's phenomenal. I wish I had it when I was doing my dissertation, but I play with it now and I have quite a bit of fun. So remember to think about Laird. You go to Laird Statistics and look for statistical test selector. I'm sure if I clicked on it, we could go out and we could see it right now. If that doesn't help, or if it's confusing, or it's not helpful to you in terms of what you were looking for, although it's got just about everything there, you can go to your G-Power manual and you can read your manual relative to your sample size and how to calculate it. Or you go to your committee, you ask your committee for help. Or you could call me. So based on the language that I gave you earlier, and again, I give that to you, just use it, paraphrase it, use different citations, but that's just an example of the language that you would use. It's very concise, very crisp. Most quantitative researchers are concise, to the point. You ask a question, they answer the question, and they don't go off on a tangent or they don't go down a rabbit hole, because that's how their mind works. It's that side of the brain that is just looking at the numerical analysis and not looking at all the words in the periphery and what all those other words mean. So, just keep that in mind. So here are a couple of things that are important in this presentation. And one is, I'm looking at the clock and I have a few minutes left here. One is to know what the effect size of your study is. And there are different types of effect sizes, and I'll try not to go into this too much. And then the other is to understand what the power is. And these two concepts, statistical concepts, are part of the G-Power analysis for your sample size. So you really want to know these things. Now you can use a Cohen's D, we call it, for effect size, depending on the statistical test you've chosen. And you can use a 0.2, which would be small, or a 0.5, which is medium. You really don't have to go to a large effect size unless your committee feels it's necessary for some reason. Correlation coefficients are considered effect sizes, and I'll explain that a little bit. Let's say, for example, you have an output of R equals 0.474. Now the R is it's a Pearson's correlation coefficient. And you have a relationship between X and Y that came out to 0.474. If you look at that, you say, I got about 47%. What does that mean? Well, what it means is that there's a strong relationship, pretty strong, between X and Y, those X and Y variables, close to about 47%. That's an effect size. It's not quite 50%, but it's pretty good. It's pretty darn good. And so that's how you use correlation coefficient as an effect size, okay? And then power. Power is really, well, so that you understand, effect size is the intensity of the relationship. So I just tried to say that in different words. The power refers to the likelihood that a researcher will find a significant result. That's what you really want. You really want to find significance when you're doing quantitative studies. But you'll still graduate, you'll still be a doctor, even if you don't find significance, because there are many different ways around it. And as long as you've demonstrated you understand the process, yet you haven't been able to reject the null hypothesis, you will still be able to graduate, and your committee will know how to help you, okay? So the power is usually at 0.80. And if you have enough information that you get a significant P, the P value, which is probability, less than 0.05 in our case for dissertations, then you'll probably be able to reject that null hypothesis, right? All right, so I want to thank you. You've been so patient, so quiet, and we will answer, I'll take comments and we'll answer questions and discussion. But I'd like to just take a few minutes, if Carrie tells me it's okay, to try to get my G-Power up so that we can maybe do a live demo. Would that be all right? Do we have few minutes to try to
Yeah.
do that? We
Yes,
do?
absolutely. We have time for that.
Okay, very good. So I'm going to stop my share here. And I'm going to try to do this. Here. Take this out. I'm going to call this up. Oh my goodness, it worked. Isn't that marvelous? Okay. So let's look at this. This
We
is what
can't see it, Dr. DUrso.
we have
We
to
still see
share.
Word.
Yeah, we have to share. Okay. Let's see if I can get it to share here.
Yep, we got it.
Yeah. Okay. So I just don't know how much to go into here because I don't want to frighten anybody off. Believe me, I really don't. But I want to just point out a couple of things about this, the features in this software that are really pretty spectacular. Okay. You have opportunities at the top to look at file, edit, view, tests, calculator, and help. And then right under that, you can look at central and non-central distributions or protocol of power analysis. I usually choose protocol of power analysis because it's a nice printout and it's a great screenshot for your appendix, okay? So come down a little ways and you can choose your test. So for us, we're going to choose an F test. And I'm going to go into linear regression, R-squared deviation from 0. Now that's the whole test. And I just want to explain before we go into the numbers here, that the big R-squared is a coefficient of determination. And some of us have been taught that that's a really powerful output. That coefficient is very important in quant studies. And the reason that it is because it gives us a percentage of the variance shared either between or among variables. So it's right there in that test. And obviously, if you start at 0, you got nothing, right? But if you start moving up into the 0.474 area, now you've got a lot of variance that's being shared between or among variables. So we chose a priori, required sample size. We have to give the alpha, the power, and the effect size, right? Notice the effect size is populated with 0.15. That's the default. That's fine. Notice the error probability is populated with 0.05. That's the default. That's fine. But notice here, 9.5, I'm going to put an 8.0 in there because GCU permits us to do our research at a 0.80 power. And I'm going to leave the 2 predictors in there. Okay. So now this column is populated, right? And I'm going to calculate. Oh, we love it when it works. It's great. So it's very similar to the sample that I gave you as your screenshot for your appendix. And here's the numerator 2, the denominator 65, the total sample is 68, and your power will be 0.80. It's all perfect. So what you'll do then for your sample size in your write-up in chapters 1 and 3, you will say this researcher included an additional 15% or 20% to the minimal 68 that were calculated by G-power. So to account for attrition, missing data, or strong outliers. Okay. So that's it. You can go into some XY plots if you want to. You can hit protocol here and get the whole printout that you could copy and put in your appendix. You can have that, and you can go to the XY plot again and do all kinds of fun things. You have this kind of an output. So you have a number of different things that you can do with this program that you can make copies of and put in your appendix. And you have to, you're required to do that if you're doing a quantitative study. So any comments or questions about this live demo here? Yes, I see a couple of hands. Mary.
Yes, I was told by someone the error problem should be like, say I have 3 predictors. I should have 017, like divide that 5 by the number of predictors.
That's right.
What
That's
would you
exactly.
say to that, Dr.
would agree.
DUrso?
Oh, I would agree, Mary. Yes. And the reason for
Okay,
that is every time you have a predictor, a new predictor that is doing an analysis or a relationship or a prediction on a dependent variable, you're watering it down. All of these comparisons water it down. And that's what you're doing when you're dividing by 3. And that's the right thing. It makes it, I'll be honest with you, Mary, it makes it a little bit harder on you to get significance. It really does. So if you can get a good sample size, that might offset it just a trifle. Okay.
yeah, I think I have a good sample size. I'm not worried about that. I just,
No,
I want to just,
that was
want to
good.
make sure that was the way to go.
It is the way to go. You were given good advice. Thank you.
Thank you.
Okay. Okay. Bamidele, how are you? You're on mute.
I'm fine.
You're fine. Good. How can I help you?
Yeah, so I'm also doing a quantitative study as well. And
Good.
when I calculated my my G power, it said I had a minimum of 82.
Okay.
And what my chair said that you may want to add 15 to that as well
Yes.
for nutrition. So like in chapter 3, where it's talking about, I think the population,
Yes.
that is where I'm going to implement that information in there.
That's right.
Okay. Okay.
That's right. So, if you wanted to, just my idea, you would round it off to 100.
Okay.
You could say, we're going to try to get 100. Are you doing a survey?
Yes.
Okay. Are you using third-party provider to do the survey?
Yeah, I'm gonna be using SurveyMonkey audience.
Okay.
But and say for example, if I don't, get, like, let's say if I don't hit 82 participants, then I'll probably use like other techniques, let's say like Qualtrics or survey or Facebook or LinkedIn, but they all have their all limitations as well.
Yeah.
So
Well, some providers guarantee you the number.
Yeah.
You pay for it,
yeah.
they guarantee the number. So think about that. Make sure that's in your contract when you sign it and before you pay. I hope you haven't paid anything yet, but
No, but
Yeah.
I did see in SurveyMonkey audience when I was doing the calculator, and I said I wanted at least, let's say, 200 participants.
okay.
And it's a very affordable price, but yeah, but I think I'll probably go in that route, but I can't really do that right now because I'm drafting chapters 1 through 3 until I get to IRB. Then that's when those information will come in, where you
Sure.
have to have the site authorization of where you're going to actually conduct your study to get your participants.
Right,
So,
right. Well, if you're going to buy 200 participants who meet your criteria, okay, that's what they should guarantee you. And you're going to pay a fee for, acquiring that list of people that are going to fill out your questionnaire or your survey, whatever it is you're using. There still is a chance that some of them won't complete the survey, that some will complete the survey, but make a mess of it. Like there are some, I have a student right now who, she looked at her data and she's got all zeros in a couple of the questions. So they filled out the questionnaire, but they just put zeros on a Likert scale. They didn't put 1 or 2 or 3 or 4 or 5. So that's invalidated those questionnaires. We can't use them. So you have to be careful, you know, that you have a good relationship with SurveyMonkey, and that they're going to do for you what you ask them to do, what's in the contract, and double check and triple check everything so that you get what you pay for. Okay.
Okay.
Does that answer your question?
Yes.
All right. Good luck to you. Good luck. Okay. Do we have anyone else that has a question? I'm going to stop sharing here. I can see you all better now. Okay.
Soroya has her hand up.
Okay, please.
Good evening.
Hi, how are you, Soroya?
I'm stressed.
Are you? Okay, well, you know, you're in good company.
So I have had 4 different sample sizes,
Okay,
3 of which my methodologist has changed.
okay,
So I was using an APO. I'm doing quantitative. I have 3 variables, comparing them to 1 variable.
okay,
So I was using a priori, and now my most recent iteration of changes or recommended changes is that I use the Bonifor, I don't know how to say it. The
Bonferroni correction.
correct. That's what she's telling me to change it to.
Mhm.
How do I know which one is correct?
Well, if you have 3 predictor variables on 1 criterion variable, you're going to need a Bonferroni correction.
Okay.
That is correct information. If you send me an email, do you know how to find me on GCU? You probably can just.
Yes, I can. Yes.